Welcome back, all my fellow mathematicians. Today you are going to learn about the Descartes Rule of Signs. Now, what is the purpose of the Descartes Rule of Signs? It is simply to provide us with an insight of how many real zeros there are of a polynomial p of x. It was René Descartes, and he is a French philosopher and also a mathematician, that came up with the rule of signs. The Descartes Rule of Signs tells us the number of positive real zeros of a polynomial and the number of negative real zero of the polynomial by simply looking at the variation of the signs. What is a variation in sign? A variation in sign is simply when there is a consecutive coefficient that is written in standard form changes to the opposite side. So you will have a positive coefficient and the next term is going to be a negative coefficient, and therefore because there is a change there, we will say that that is one variation in sign. Then you look for the change from that negative coefficient to see if the next coefficient is going to be a positive coefficient, and if it is, then yes, that is a second variation in sign. Another thing that you need to know is that the number of positive real zero of a polynomial p of x is either the number of variation in signs of that p of x, or it is less than that number by an even whole number. So therefore, in other words, when you look at p of x and you have three variations in signs, you are either going to have three positive zeros or you're going to have one positive zero. So if you apply p of negative x to the polynomial and you end up with, say for instance, three variations in signs, you will end up with either three negative zeros or you will end up having one negative real zero. And I'm going to get into this. So if we're given this polynomial p of x is equals to x to the third power plus x to the second power minus x plus 1, and we need to apply the Descartes Rule of Signs to this, we are going to look at this polynomial and determine the amount of variations that we have in signs. We will have a positive sign here, and this is moving to a positive, so that is no variation. But moving from a positive to a negative, this is one variation in sign. And then moving from a negative to the next term, which is positive, this is a second variation in sign. So now that we know that we have two variations in sign, we can say we have two variations in signs. And so we can now state that because we have two variations in signs here, we can now state that we will end up with two positive real zeros or zero positive real zeros. Now, one thing I must say to you is that because you have 2 here, you have to subtract 2, which that is how you end up with or 0 positive real zeros. So now that we know that we have a possibility of 2 or 0, we need to find out how many negative real zeros we can have from this. And in order to do that, we must find p of negative x. And p of negative x, because if we substitute negative x wherever we see x, and that will help us to determine the number of variations in sign and also the number of negative real zeros. So we notice here that when we have evaluated this, we will end up with negative x to the third power will simply be also be negative x to the third power, and because negative x to the second power is going to be simply be positive, this will be a positive x squared, and these two negatives side by side is going to be a positive, and also you have your positive 1. Now you'll notice here that your first term that has the coefficient there is negative, and going from negative to positive, that is one variation in sign. And this is a positive, we'll go to a positive. We have no more variation in sign here. It's just simply one variation in signs. So therefore, we have simply one negative real zero here, or it could be none. Now, another thing I must state to you is that if you look at your polynomial that's given to you and you look at the highest exponent, which is 3, therefore we know that we will end up with 3 possible zeros, and we can form our column over here. So we form our column by saying we have our positive and we also have our negative, and the other one could be a complex number, or what we call the I. So, and we can put T for our total. We know we need 3 here. So for the first one, because we did the variations in sign here, and we know that we can either have 2 positive here, but if we have 2 positive and we also know that we have 1 negative here, then we know we will not have a complex number. Or if we have 0 positive, then because we have 0 positive and we have 1 negative, we can have 1 negative here, then we will end up with 2 complex numbers. Or the other possibility is that if we have 0 negative and 0 positive, we will end up with simply 3 complex numbers. So we have to do our table, and that will guide us to know the possibility of our zeros that we will end up using our variations in signs. So let's do another example. So the next example that we're going to look at is P of x is equals to 2x to the 4th power plus 3x to the 3rd power minus 4x to the 2nd power minus 3x plus 2. By looking at the polynomial here, we can determine that we will end up with 4 real zeros. We're going to test to see how many of these zeros are going to be positive and how many are going to be negative, and if there are also going to be any possible complex numbers. So let's determine the amount of variations in sign for this polynomial. So the change from positive to negative occurs here. There's no variation here, but there is a variation here. So we can say we have 2 variations in sign. And then we can also state that because we have 2 variations in signs, we can also further state that we will end up with 2 positive real zeros or 0 positive real zeros. And now we need to test to find out how many negative real zeros we will end up with, and we must test it with P of negative x. So P of negative x, going back to our original function, 2 negative x to the 4th power plus 3 negative x to the 3rd power minus 4 negative x to the 2nd minus 3 negative x plus 2. So because we have to the exponent 4 here, this is going to simply be also a positive. So we have 2x to the 4th power. And because negative x to the 3rd power is going to be negative, so we end up with negative 3x to the 3rd power. And you will have negative x to the 2nd power is going to be positive, but you have a negative 4 here, so it's negative 4x squared. And negative 3 times the negative x there is going to be a positive 3x, and you have your 2, which is the constant term. So let's look for our variations in sign. So we know this is a invisible plus sign here, and we're going from plus to minus, that's one variation there. We notice that there's a movement here from negative to positive, so that's the second variation in sign. So in this case, we have two variations in sign here, and so we will end up with two negative real zeros or 0 negative real zeros. And so let's do our column. So with our column, we have our negative, we have our positive, we have our complex number, and our total. So the negative, we have two negative, and we also have a possibility of two positive. Then we will end up with 0 complex numbers because our total number of zeros must be 4. And then because we know that we will end up with two positive real zeros or 0 positive real zeros, we can put our 0 here as the next option. And if we have 0 here and we still have our two negative real zeros there, so we have our 0 here for the positive and 2 for the two negative zeros here, then we will end up with two complex numbers in this case, and our total here will be 4. The next option is that if we have 0 negative, as we have here, then we can also have the two positive, and we can also have the two complex numbers, and we still end up with 4. And the last one is that if we have the 0 negative, as stated right here, and also the 0 positive, we would end up with 4 complex numbers, and our total there would be 4 zeros for this polynomial. So one thing I'm going to say to you, when you use the column, that will help you, because then you get a visual picture of what the amount of possible positive zeros will be, and also what the number of possible negative zeros will be. Now let's do one last example. In this example, you will notice that the highest exponent here is 5, which is telling you that you are going to end up with 5 zeros. And so we must first determine how many positive zeros we're going to have and how many negative, and then what are the possibilities of the complex zeros. So let's look at the variations in sign. So we see here we have a positive is going to a negative, so that's one variation in sign. We don't have any here, but over here we have another variation in sign, so that is just simply 2 variations in signs. So this means we have 2 variations in signs, and because of that we have 2 positive real zeros or 0 positive zeros. And I use this to show that that means positive. So let's look at the P of negative x to determine the amount of negative zeros that we will have. So P of negative x, and we are going to simply substitute negative x where we see x, let's simplify this. Because our exponent is odd, this simply means that we will end up with a negative value here for the x. So we have negative 2x to the 5th power. And because this exponent is even, then we will end up with a positive x here. So it's going to be positive x to the 4th power. This is going to be a negative and a negative with a negative 8. is going to be a positive 8x to the third power. This is going to, sorry, I didn't put this negative x there. This is going to be a positive x, so it's negative 4x to the second power. And we will have negative 6x here and plus 9. So we can determine now our variations in sign. So we have 1 here. And we also have another variation in sign here. That's 2. And we have a third one. So now we can say we have 3 variations in signs. And we also can say we have 3 negative real zeros or 1 negative real zero. So now that we have that, we can set up our column, and I will put a positive here, negative, our complex I, and our total. So our total should be 5. We already know that we should have 2 positive real zeros there. So we have 2, and then we would have 3 negative. So therefore, we have a possibility of 0, complex 0 there. And so the other option is that we would have 0 positive real 0 there. And so we have 0 right here. And if we have still the 3 negative right there, because that is another combination, we will end up with 2 imaginary numbers, or what we call complex zeros. And so our total is 5. But we can also note that we can also have our 2 positive real zeros, and we have our 1 negative real 0, and therefore we will end up with simply 2 complex zeros, or 2i, and this would be a total of 5. The other possibility also is that we could also have 0 positive, and we can also have our 1 negative. We will end up with 4 complex zeros, and our total here will be 5. So you have to look at those possibilities also. And when you look at these, this will give you a general picture of what is going on in terms of the options that you will have, because you can either have 3 negative zeros or you can have 1 negative 0, whereas here you can either have 2 positive zeros or simply 0 positive zeros, and then you will just simply look at the other variations that you have over here. So now that you have your column there and you use the Descartes Rule of Signs to determine your possible positive or your possible negative or your complex zeros, you can also go further and simplify this if you're asked to find the actual zeros of the polynomial. And in order to do that, you would go back, you apply the rational zero theorem, where you list the possible rational zeros, and then you can test them using the synthetic division method. And then after doing that, and further factor out and determine your positive zeros. I'm going to do a video on that, so look forward to seeing an upcoming video on how to find all the zeros of a given polynomial. I hope that this video has helped you tremendously, and now that you know how to determine the variations in sign for the positive real zeros, and also come to the conclusion of how many positive real zeros you will have, or the amount which is less than the whole number. And since you also know that you have to apply your p of negative x to your polynomial to determine the number of variations in sign, and also the number of negative real zeros that you will have in that polynomial. Thank you for watching, and if you have not yet subscribed to my channel, please go ahead and hit the subscribe button. Thank you and see you soon. Bye now. Cheers.